Hello class. Let me adjust. Ayan. So in this video, I'll be discussing the other conceptual uh, question in our PowerPoint for classes of forces. Okay. So this is focusing on static and kinetic friction. So the scenario is, or the situation is that we are given 5 different cases here, but the box and the floor here are identical in all of the situations. Only the conditions are different. We are to rank the friction, whether it's static or kinetic, rank the frictional forces FA to FE, okay, from largest or strongest frictional force to the weakest friction force. Okay, so what are the cases? In case A, it says here that no one or nothing is pushing the box here and it's not moving. But if you notice, if you look at the PowerPoint and even in the drawing here, the lengths of the lengths of each friction here, okay, were really intentionally drawn to be of the same length. Okay, so that the length of each friction cannot be used to answer the question here. Otherwise, kung pinakita talaga na ang weakest is shortest, ang longest ang greatest, edi wala nang sense na magtanungin pa tayo. Okay? Kaya wag kayong ma-confuse. Talagang dinraw yan of the same length. Kasi pag nag-analyze na tayo, saka na natin ilalagay yung appropriate na relative lengths ng mga arrows for friction. Okay? So, case A, hindi gumagalaw, walang nagatulak sa iya. Case B, it's just on the verge of slipping. Okay? Kanang mo start pa lang gid siya slip, no? So, itong molecules under ng box natin dito, the surface, okay? Now, if you look at it microscopically, ang surface contact ng ilalim ng box at saka ng sahig, the adhesive force, okay, is just starting to break loose. Kaya on the verge of slipping pa lang. Other authors will call this as the box starts to slide. Pwede ring sabihin na commonly na the box begins to move over the floor or to slide. Okay? Okay, there's a pushing force here and then you have the friction force B. For case C, this time it's still being pushed to the right. Friction, of course, we know that it's a kontrabida force. It will always oppose the applied force. And then it's speeding up to the right, ang case C. Si case D, the box still receives a pushing force to the right, but the box here is moving at constant speed in a straight line, so its acceleration along the x is 0. For case E, the box is still being pushed to the right, however, it is slowing down. So the velocity is to the right, acceleration is to the left, so this box will slow down. Okay? Now, before we to help us analyze in comparing the relative strengths of the friction forces here, let me discuss a bit about static and kinetic friction. No? The discussion of this is also can also be found in the same PowerPoint. But I want to emphasize the concept of friction, no? Kasi it's very fundamental and it's very helpful. And most of the time when we are analyzing systems, critical na ma-determine you correctly kung static or kinetic or kung wala at all. Walang problema kung sasabihin ka agad sa sitwasyon na the surfaces in contact are very smooth. So pag ganon, wala na question, zero friction na gid na. Otherwise, meron. Okay, so let's start with this one. Okay, let me put this closer. Okay, I have drawn here different scenarios pa rin, no? Para madali nating masagot yung question. Okay, so ano bang characteristic ng friction. Friction, big sabihin, it's a resistive force. Kaya nga, pag meron kang, let's say, naka-argue or naka-cold war, pwedeng sabihin, may friction ako with him or with her. So, parang nagko-contradict yung tawag dito, mga ideas nyo, kumbaga. So, in the physical world, ganun din somehow ang meaning ng friction, okay? There are cases na nuisance ang friction, kanang makalagot siya, no? There are times also na kailangan mo siya. Say, for example, the mechanics of walking, if the floor is frictionless, then walang enough na traction to hold para maka-push back ka sa ground, and then the ground will push you forward. So, dili ka kalakaw. So, that's another very important contribution of friction, no? Otherwise, di ta kalakaw kay kanang walay traction. But anyway, so ganito siya. So, if you have just an object that is resting there, nya wala may puwersa, no? Take note na si friction, static and kinetic, ang orientation niya is along the axis where the two surfaces are in contact. So, if the surfaces in contact are oriented horizontally, then si friction naalang yun diha sa axis, either left or right. Kung asa ng motion, yun yung kukontrahin niya. Now, so in this case, nakatunganga lang man ang box natin dyan, walang force na kukontrahin. So, in this case, friction, static friction, is 0. Kasi walang kukontrahin. So, pag at rest, nakuha ba? Okay. Kasi si static friction, i-oppose niya ang possible start ng motion. Okay? So, yun si static friction. But what if this time, yung same box na yan, pinush ko to the left, pero hindi pa rin siya gumalaw. So, meaning, since meron na tayong force ngayon na parallel, no? This force is parallel, the same axis with the bottom of the box and the floor. So, big sabihin nito, pag push niya to the left, hindi gumalaw according to Newton's law of inertia. Dapat balanse ang forces dito sa x-axis para ito manatiling at rest. So, kung tinulak ko siya sa left, hindi naman siya gumalaw, that's because si static friction, same length yan siya dito. So, the static friction here, ang strength niya equal sa in-apply ko na force and opposite. So, pag in-apply mo ngayon dito si first law, mag-add ka ngayon ng dalawang opposite signed numbers of equal strength. Kaya, ang net force dito, 0. So, in this case, hindi siya gumalaw. Tama ba? Next, what if itong, I'm really desperate. Gusto ko talagang mag-move ang box na ito. So, in-increase ko yung force ko. Sabi ko, okay, kusgon daw na ako ni og push be. Kaya lang, medyo stubborn ang box at saka itong kuan, nagdikit yung tiyag maayo. So, nilakasan ko yung applied force ko, pero hindi pa rin siya gumalaw. So, what can you say about the friction? Yes, nag-increase din siya to the point na, so lagyan ko pala ito ng magnitude, no? Kasi ang magnitude lang nila ang equal, opposite ang direction nila. So, in this case, lumakas din si static friction. So, magkasing haba yan sila more or less. So that, ang magnitude ni static friction equal pa rin sa force na in-apply ko. So, hindi pa rin siya gumalaw. Tama ba? Pero, sabi nila, walang forever. No? So, meaning, in this case, hindi din unlimited yung kayang i-provide ni static friction. Meaning to say, merong certain limit, no? So, let's say, in-increase ko pa siya konti, mas malakas yung force ko dito ngayon. If the applied force now is, tawag nito, a bit greater, okay? Magsugod lang siya, gamay lang nga mas kusog, than the maximum static friction, ang strength nito, then, the box here will start to slip or to move. In that case, so meaning, hindi pwedeng maging unlimited ito. So, ang maximum static friction, different ang values niyan. Depende yan sa kung gaano kabigat yung object na nasa floor at saka kung anong klaseng materials made of ang floor at saka ang box. No? So, the number that somehow gives us a clue kung smooth ba or rough ba yung two surfaces in contact, the number that describes that is the coefficient of static friction. So we say mathematically that si maximum static friction, this is directly proportional to the normal force. So, ito siya. 'Di ba may floor sa ilalim? So, ipupush niya yung table dyan. So, kung ipapakita natin ang free body diagram, may normal force na paakyat. And the normal force is normal to the floor, 90 degrees with the floor. Merong mass ang box, so meron ka pa ring gravitational force. Magkasing haba si normal at saka si gravity here kasi yung box natin walang acceleration sa y. So, zero acceleration in the y at saka dito, zero acceleration pa rin siya sa x kasi begins to slip pa lang. So, pag sinabi sa problem na mag-start pa lang gagalaw yung object, under pa rin siya sa system in equilibrium. First law pa rin muna ang gagamitin mo. So, in this case, you have here the Fs maximum. Yan. So, you need a greater applied force if the maximum static friction between two surfaces in contact is strong. And that static friction na kailangan mong kontrahin para lang ma-start ang motion nito depends on two factors. Number one, the strength of the normal force acting on the box and the nature of the materials in contact itself. The coefficient, this is Greek letter mu. That's Greek letter mu. Parang M at saka U, gisagol, gihimog mu. And then, lagyan natin ng subscript S. So, the greater coefficient of static friction, it means medyo rough yung dalawang surfaces in contact. So, pag malaki ito, malaki din ang maximum na kaya ng friction na i-provide. Kaya mas kailangan mo ng mas malakas na force para malampasan yan. So, kumpletuhin na natin ang equation. Ito na ngayon si static friction. Okay? It's now equal to static friction. Now, so si coefficient of kinetic friction, this is a pure number. So, pag sinabi kong Fs, pwede namang hindi na natin ilagay si max, understood na yan na max, divided by the normal force, this will give you the coefficient of static friction. Static friction is a force, so its unit is Newton. Normal force, obviously, is a force. So, Newton divided by Newton, ito walang unit. Okay? Pag masyadong rough ang surface, ang mu s nasa 1. Let's say 1.00. Pag masyado siyang very, 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 very smooth na frictionless, magsi-0 ito. So, for every pair of two surfaces, ang iyahang static coefficient of static friction can be equal or tawag nito. So, you have here 0, equal, and then this one will also be equal or less. So, si mu s is a positive number between 0 and positive 1. So, walang negative na mu s. At saka wala ding mu na lalampas sa 1. Kasi, physically, it's not possible for static friction to be greater than the normal force. It's physically impossible. Kaya never mangyayari na mas malaki ang denominator kaysa numerator dito. Because physically, si mu is, ang maximum lang na kaya niya is 1. Okay? Ayan. So, meaning to say, pag static friction, ang involved na law is still the law of inertia or the first law of Newton. Okay? Now, if in case mag-move na siya, mag-slide na siya, so let's go to kinetic friction naman this time. Okay.